In this video, we're going to talk about how to solve rational inequalities, and hopefully we've been following the series, so we recognize how to solve polynomial inequalities, and we could do that either graphically or via sign analysis approach. And I try to avoid doing it graphically as much as I possibly can, only because it's not as analytical. I like the computations because I think they're more supportive in nature. So if we want to solve rational inequalities, the best thing that I can recommend is performing that sign analysis. That sign analysis is going to be the strongest tool that you have in order to solve these rational inequalities. However, the difference between identifying the critical points of a polynomial and a rational inequality is that critical points of a rational inequality will not only be the zeros, but they're also going to be the vertical asymptotes. So at the zeros, the function can change sign. It can go above or below the x-axis, but also at vertical asymptotes, they can go and change signs as well. If we look at it, for example, let's say that we had some value, we'll call it c, and we had a vertical asymptote that existed at this value. Our curve could be coming in here and stay positive, and then it could shoot down from the bottom and then become negative. So we recognize at vertical asymptotes, our curves can also change sign from positive to negative. I will put a special annotation here is because no x values of vertical asymptotes, I'm running over my graph, can be included in your solution. So hopefully you can read that. This just says that the domains have to exclude vertical asymptotes. So even though they're going to be part of the solution, we will always have to enclose them with a set of brackets because we can't include them in our solution. So let's go ahead and look at an example of a rational inequality. Let's go ahead and say I wanted to determine where x minus 3 all over x plus 4 is less than or equal to 0. So we want to figure out where is this rational function less than or equal to 0. So the first thing that I like to do is that I like to identify my zeros, because my zeros are going to be one type of critical point. We're going to identify our zeros by setting our numerator equal to 0. Our zeros will be determined by setting our numerator equal to 0. So we can add 3 on both sides, so we get x is equal to a value of 3. This will be one critical point. Our next critical point we can determine is by setting our denominator equal to 0, and that's going to be our vertical asymptote. So I'm always very careful when I see this, because when I set my denominator equal to 0 to find this critical point, I am really also finding my vertical asymptotes, and I'm also determining my domain. My domain of this problem, for example, my domain would be where the denominator cannot equal to 0. So it would be x such that x cannot equal to negative 4. So domains and vertical asymptotes are very intercorrelated, and that will also mean that when evaluating inequalities via sign analysis, we're going to have to pay very close attention to this critical point. But I always like to make note that no matter what I do, I can never ever include this value in my solution. So be very careful of that. Following the exact same process we had with polynomial inequalities, we're going to go ahead and draw a number line with our zeros in ascending order. So I'm going to have my first zero at negative 4. My critical points in ascending order. So I have my negative 4 first, and then I have my positive 3. I'm going to even go as far as drawing a little x, a little faint x over this value to make sure that I know that I cannot include it because it's a vertical asymptote. So I recognize that I could be changing signs in 3 different intervals. So I could be changing sign in this interval, and this interval. Well, I'm not actually going to be changing sign. I could have signs that differ in those 3 intervals. Now I'm going to write my factors. My first factor is going to be this x minus 3. So I have my first factor of x minus 3. And then I'm going to have my second factor of x plus 4. I'm picking different colors here. So let's see if I pick this right. X plus 4. There we go. So x minus 3 corresponds to the critical point of 3. Pick a value to the right like 4. 4 minus 3 is a positive one. So to the right, x minus 3 is positive. To the left, he is negative. X minus 4 corresponds to the critical point, the vertical asymptote point of negative 4. To the right, pick a value like 5. 5 minus 4 is positive, so to the right will be positive, to the left will be negative. So if we want to determine our functional value, notice we are dividing. Notice we are dividing in this problem. So a positive times a positive is the same as a positive divided by a positive. A positive times a negative is the same as a positive divided by a negative. And a negative times a negative is the same as a negative divided by a negative. Those sign rules are consistent no matter if you're multiplying or dividing. So you could say a negative divided by a negative or a negative times a negative. You're still going to get the exact same outcome. So a negative times a negative or a negative divided by a negative gives you a positive. A negative times a positive or a negative divided by a positive gives you a negative. And then a positive times a positive or a positive divided by a positive gives you a positive. So now our problem asked, where is our function, rational function, less than or equal to 0? So where is it negative? So where is it negative? It's negative from -4 until, so -4 until 3, because it's negative between -4 and 3. But we will never include the point -4 because that's a vertical asymptote. So even though there is a less than or equal to sign, we're going to enclose this with a parenthesis. However, since 3 is a 0, we're going to enclose that with a bracket. Let's expand this problem. Let's say that we asked, where is this problem just less than 0? Where is this exact same problem? So this exact same problem, where is it less than 0? So that's going to be a very similar interval. It's going to go from -4 until 3, but we're not going to include either one of these points because it is just less than 0. So let's say that now I wanted to determine where is x, let's just use a different color. Let us use pink. Where is x minus 3 all over x plus 4? Where is this greater than or equal to 0? So where is he positive? He's positive here. So positive from -infinity until, actually I'll do the answer slightly above. So -infinity until -4, but we can never include -4 because that's a vertical asymptote. And then he's positive again, starting at 3 and going to positive infinity, but we're going to include 3 this time because at 3 we have a 0. Infinity we're not going to include. We never include negative infinity or positive infinity. And then last, let's say I asked, where is x minus 3 over x plus 4? Where is this greater than 0? So no longer the greater than or equal to. So he's greater than, he's positive, greater than 0, positive, and positive. He's positive from -infinity until -4. But we're not going to include the -4 because we can't, and also because it's just a greater than sign. And then we start again at 3 and go to positive infinity, but we're not going to include 3 this time, and we never include our infinities. So notice these problems have very distinct ways of tackling them. However, the sign analysis really unifies this process. But remember, when you work with rational functions, never include the vertical asymptotes.